Hi guys, this is Miss Gold. Today's lesson is Module 6, Lesson 6, Volume of Right Prisms and Composite Objects. Your outcomes for today's lesson are students use the formula V equals B times H to determine the volume of a right prism. Students identify the base and compute the area of the base by decomposing it into pieces. And students compute volumes of three-dimensional objects composed of right prisms by using the fact that volume is additive. Now, volume is similar to area, but for three-dimensional figures. And the main idea of how you would calculate volume is you first have to identify what the main shape is that makes up that three-dimensional figure. And so how you want to think of this is you think about what shape is repeatedly stacked to create the three-dimensional prism. So our formula here is going to be the volume of a prism is equal to B times H. Now notice I've used capital B here, and that is actually going to represent base, meaning the area of the base figure. So it's very important for you to identify what is the base figure of this object, what is repeatedly being stacked to create the three-dimensional figure. Let's take a look at example 1. Example 1 says, find the volume of the following three-dimensional object composed of two right rectangular prisms. So we have two different right rectangular prisms here, and so probably the approach we want to take here is to break them up into two separate right rectangular prisms and find the volume of each. So let's actually label these 1 and 2. Now the general formula for this, volume of a rectangular prism, is actually given to you on your reference sheet as length times width times height. And I want you to notice this still fits the idea that we just talked about on the previous slide, because this represents the formula for area of a rectangle. And that is the base figure of both of these rectangular prisms. So if we want to find the volume for each, let's find the volume of 1 first. So for volume of 1, we have a length of 4, a width of 5, and a height of 5. So when I multiply those, we get 4 times 25, which is 100. Now you always want to add the units to this, and these units are meters. And what you want to realize is when we did area, it would have been meters squared, but this is a three-dimensional object, and we multiplied 3 different elements to get this. So it would have been meters times meters times meters is meters cubed, or cubic meters. Volume of the second right rectangular prism is going to be a length of 10, a width of 10, and a height of 3, giving us 100 times 3, which is 300 cubic meters. And finally, we'd want to find the total volume, or the volume of the whole figure. So we found the volume separately, so we would want to add those together. So we would do 100 plus 300 gives us a final answer of 400 cubic meters. So this is probably the most basic kind of problem you're going to get, and this is usually the easiest for students to understand, is that length times width times height. When you start working with more complex figures, it doesn't need to be more difficult. You just need to identify what the base shape is so you can identify what the formula of that base shape is for the area. Along those lines, let's take a look at example 2. It says calculate the volume of the following prism. Now, let's take a look at what this prism is made up of. You notice what I have here is it has 4 sides in terms of the base shape, but I'm not given the lengths or widths of the sides. I'm actually given the insides of it, and that leads me to believe that I really need to break up this prism into 2 different parts at least. And there's different ways to break it up. You can see here that we have 2 different triangles here. If I broke it up this way, we could find the base and height of that triangle, and then the same thing for this one. So that's one way to do it. The other way is that we could break it up into this triangle versus this triangle. And I think that's the approach we'll take for this one. So let's number these. Let's call this main triangle in here triangle number 1, and we'll call this one in here triangle number 2. Because we're dealing with triangles, the volume of a triangular prism is going to be base times height. So we want to know the capital B is the formula for area of a triangle. So we know area of a triangle is 1/2 base times height. Now, because I already have a height in the formula, I'm actually going to give this a little sub-triangle here so that we know that we're talking about the height of the triangle and not the height of the prism. And then it would be multiplied times the height of the prism. So using that formula, let's plug into the two different triangular prisms. So we have 1/2 times the base of this figure here. Number 1 is 18, and the height is going to be 20. And then we're multiplying it times our height of 3 over here. And when I multiply those out, I get 540. And this is in inches, and again, it is volume, so it is cubed. Volume of the second triangle, again, is 1/2 times the base is still 18 of this triangle, but the height is only going to be 4. So 18 times 4, and the height of my prism is still going to be 3. When I multiply those, I get 108 cubic inches. And so the volume of the whole figure is just going to be the sum of those two. So 540 plus 108 gives us a grand total of 648 cubic inches. So in this one, we chose to actually break our prism down into two different prisms. All right, let's take a look at example 3. It says a container is shaped like a right pentagonal prism with an open top. When a cubic foot of water is dumped into the container, the depth of the water is 8 inches. Find the area of the pentagonal base. Now notice in this, we're not actually asked to find anything other than the area of the base. So really all we need here is our regular volume or our general volume formula. So volume of a pentagonal prism is simply going to be base times height. So I'm looking to find this. So in order to find that, I would need to know the height and the volume, which they actually do tell us here. First, it says a cubic foot of water is dumped into the container and it creates a depth of 8 inches. Now that is actually going to give me my height here, and the cubic foot of water is going to be my volume. So let's go ahead and plug those into the formula. So we have 1 cubic foot is our volume. We don't know our base, so we're going to leave that as capital B. And then I do know that the depth of the water, or the height of the prism, is going to be 8 inches. And what you should notice at this time is that we have an issue. We notice that this is in cubic feet, and this is in inches. If this was feet in feet, it'd be fine, or inches in inches, it'd be fine. But we need to make sure that these are the same, and they're not. So we need to change one of them into the other. Now, a lot of people like to turn feet into inches because they know they can just multiply by 12. But you got to remember that this is not just feet, it's cubic feet. So I'm actually going to choose to turn my 8 inches into feet by dividing by 12. All right, so what I have here is 1 is equal to, I'm just going to rewrite this without all of our units. And if you wanted to, you could reduce the 8/12. If I want to solve this, I have two choices. I can divide by 8/12, or I can multiply by the reciprocal. And I like to do that, so I'm going to multiply by the reciprocal. And if I do it to one side, I got to do it to the other. In fact, let's draw our wall. So I'm going to multiply this side by 12 over 8. That's going to cancel my 8 and 8 and cancel my 12 and 12 over here, leaving us with just the base, which is what I wanted to find. And this is going to give me 12 over 8. And this actually reduces to 1.5. And this is an area, so this is going to be feet squared, or square feet. Okay, let's take a look at our last example, example 4. It says, find the volume of the right prism shown in the diagram, whose base is the region between the two right triangles. Now, one of the most important parts of this is the fact that they state that it's two right triangles. So if we see here is our right angles in both of these triangles, that will tell us that our base is located here. So we could say that this is a base and that this is a base. and then that this would be the height. And I'm going to put height with a little sub triangle here, and same thing over here. And then this right here is going to be our depth, or the height of our figure. Now, we have to come up with an approach of how to actually go about solving this. So if I notice I have an entire three-dimensional prism, but within that there's a chord out section of that. And so really my strategy is that I'm going to find the volume of the entire prism and then the volume of the inner prism, that is the chord out section, and subtract that section out from the larger. So here's my strategy. Volume is equal to the volume of the large minus the volume of the small prism. So let's start with our formula. So volume of our triangular prism is going to be base times height, which in this case is 1/2 times base times the height of the given triangle times the height of the prism. So let's start by finding the volume of the large triangular prism. So we know that it's going to be 1/2 times 3 times 4 times 4.5. And you can see where I got those from. 3 is going to be my base, 4 is going to be my height of my triangle, and then 4.5 is going to be basically the depth, or the height of the prism. And when we multiply that out, we get 27, and this is in centimeters, so it's cubic centimeters. Then we want to find the volume of the small. So we have 1/2 times 1 1/2, and that is our base of our small triangle. Our height is going to be 2, and the depth of this is still going to be 4.5. And when I multiply those out, I get 6 3/4 of a cubic centimeter. And so let's go back to our general strategy, which was to subtract the two. So we are going to take 27 and subtract out 6 3/4, giving us a final answer of 20 1/4 centimeters cubed, or cubic centimeters.